The Best Way to Explain It, Episode 15. Podcast listeners, welcome back. Another episode of The Best Way to Explain It, the podcast where we only use the word moist when necessary.
I love moist towelettes.
This is the moistest podcast ever.
Remember when we were in praise band for our church group in college?
Yeah.
And we would say moist kiss instead of sloppy wet kiss just to annoy everyone?
Yeah, because... Okay, why is moist a word that people don't like?
Well, what do you think of when you think of moist?
I don't know, a cake?
Okay, you think of a cake. I think of a sponge that is like cold and damp and it's moist, you know? But I also understand like a moist cake or something like that too. Okay,
yeah. No, like that's just, somebody describing a cake as moist is like that's a positive,
Yeah. And now that we've said moist like 18 times in the first minute, everyone hates us.
Yeah, this is a moist podcast because moist means good.
Sure. I think moist has different meanings depending on the context.
That's fair.
Yeah.
But we've only used it when necessary.
If only we were sponsored by like an underwear company so that we could talk about like staying moist free. Yeah.
There we go. Or moist towelettes.
There we go.
See, they're fine with it. Their industry, like that, they've embraced the term.
Well, they've embraced the term, but it's also a bad thing. It's all about moisture wicking technology.
Okay.
Yeah.
I don't know what that is.
It takes the moistness out of your nether regions.
All right. Well, this devolved. But seriously, add moisture wicking technology to the backlog of episodes we have planned.
All right. Cool.
All right. That'll be the dullest episode ever.
Can't wait to explain that one, Scott. Thanks.
I'll take it. Oh, man. All right.
So now that we've talked about that, how about we talk about something that you don't want to be moist?
Hey.
Like
probably
the internet.
Actually, it totally that's a bonus actually. So
yeah,
no, it is not. So guys, yes, like you said, we're on the last episode of this series on the internet. I know you guys are really happy that I'm finally gonna be talking about something other than the internet.
I'm doing a dance in my room right now.
Yeah, you're about ready to be done with this series.
Well, it's the less I have to sound dumb talking about the internet that I know
That's
nothing
fair.
about. So,
well, now you know more.
Yeah, at least you've helped me.
Indeed. All right. So, last layer. Are you guys ready?
Oh yeah.
And by you guys, I mean you.
Yeah, I'm ready.
Because the audience can't really.
I had to think for a second. I was waiting for you to like input some noise in the background. Like we promised we wouldn't have canned laughter, but we were gonna have like canned cheers and stuff.
Yeah, applause.
Yeah.
Sounds good. Okay. All right, guys, we are finally here, the final layer of the internet. So after this episode, you're going to understand the entire internet, more or less. Okay, so there's obviously always more that you can learn, but you're going to at least have a framework on which you can like build your knowledge. And what I mean is that there are so many different protocols and technologies that we could talk about on each layer that we've talked about so far, but as long as you kind of understand which layer you're talking about, it's fairly simple to just read about the specifics and then extrapolate like, okay, that's on this layer of the internet. Though sometimes protocols don't fit so nicely into our model that I've been talking about in this series, but, deal with it. I do what I can. All right, so we are going to talk about the application layer of the internet. So that'd be layer 5 in our model. So what is the application layer? So like what problem is it trying to solve? Well, applications are just, things that run and use the internet. So if you remember back to the last episode, the last internet episode, the best way to explain it.com/13, where I talked about the transport layer. The transport layer established connections between these different applications. But the applications themselves need to have their own sort of designated format or way in which information is structured, as well as having a format for the many different, conversations, quotation marks, that an application might have within its connection. And that's what this application layer is for. So an application would be anything that uses the internet, basically. So your web browser is an application. Online video games would be an application. These all have specified ways of how communication ought to look. And so up until this point, most of the layers we've talked about have had both an address and a PDU, or a protocol data unit. But the application layer really doesn't have that concept. In fact, talking about this as a layer in the way that like the link and the network and the transport layers are layers really isn't, I think, a very accurate term, in my opinion at least. It's better to think about it in the way applications act within the connections established by the transport layer. So the application layer includes the protocols used by most applications for like providing user services or exchanging application data over the network connections established by the lower level protocols that we talked about previously. So in fact, like any application that uses the internet is going to use an application layer protocol or define its own, right? So it's going to assume that every layer beneath it is working fine, but it doesn't really concern itself with like the intricate details of how the networking is laid out or the connections are established. And to be honest, that's really it as far as the application layer, like of abstractly what it is. The real specifics are in the commonly used protocols within the applications themselves. So each protocol basically says, hey, if you want to share information on the network using this specific application, here's how it needs to happen. And since the application layer is so wide-ranging in terms of the specifics, I'm just going to talk to you about some of the more commonly used application layer protocols that you might see or use. So application layer, does that concept kind of track?
Yeah, that makes sense. So
Okay.
It's not really a layer, it's how it acts within the transport layer. Kinda.
More or less
All
would
right.
be the,
Cool.
good way of thinking about it.
Yeah.
So the first protocol or application layer protocol that I'm going to talk about is HTTP. Now, you've probably seen this before. It's probably the most common application layer protocol. So HTTP stands for Hypertext Transfer Protocol. Now, you've likely seen HTTP:// in your browser's URL. This is because it's the protocol which is the foundation of data communication on the World Wide Web, the thing that you use all the time, what we commonly refer to as the internet. In other words, it's like the protocol used by web browsers and web servers to communicate with each other over the internet. So if you think about it, your web browser is just another application, right? It's just another application on your computer. Well, it's the primary application you use when you want to look at data on websites. It just needs to know. It just knows that it needs to use HTTP in order to understand and communicate with those websites. So the website and the web browser are just the two applications that are sending data back and forth to each other. So it'll need an application layer protocol to define how this type of communication is supposed to work, and that's what HTTP is for. So HTTP is a connectionless text-based protocol. So that means that each time a request or response is made, a new connection between the client and the server needs to be established. So if we talked about the client and server back on the previous internet episode. So the client is just what kind of initiates the connection. The server is going to serve up the data that the client wants. And that's all that means. So this connectionless text-based protocol is going to make more sense. That's a handful. So the connectionless text-based protocol is going to make more sense once we kind of understand how the HTTP works. So this HTTP is also media independent, which means that as long as both the client and the server know what to do with the data being sent, then like any type of data can be sent using HTTP. And then finally, it's a stateless protocol, which means that it doesn't hold any information between connections. The client only knows information about the server while a connection's established, and vice versa, the server only knows about the client. And so after the connection's interrupted, the client and server don't really know anything about each other unless you've explicitly set it up to track that information when you're outside of the HTTP protocol. And I just realized saying HTTP protocol is redundant because then you're saying hypertext transfer protocol.
It's kind of like ATM machine.
Yeah, exactly.
Yeah.
Oh, pet peeves.
Yeah, it's one of those things. I never notice it until someone brings it up, and then it annoys me a little bit, and then I get over myself.
Yep. And then you're like, wow, I'm really
pretentious about words, I guess.
Yeah.
Yep.
That's the way we are. All right. So in order to really understand HTTP and the many different concepts and protocols we're going to talk about in this episode, we need to talk about the World Wide Web.
Ooh.
All right. So the World Wide Web, we talked about this all the way back in part 1, which I believe was episode 5. So if you go to thebestwaytoexplainit.com/5, you will know what I'm talking about. So I mentioned that the World Wide Web was first created by a guy named Tim Berners-Lee. This is likely what you've always thought the internet was, but it is not, in fact, synonymous. It's the system of interlinked hypertext documents accessed through the internet. That's what the World Wide Web is. So in other words, the internet is used to look at documents that aren't stored locally on your computer. So these documents are what we think of as websites. We access the World Wide Web, which I'm not going to keep saying the World Wide Web. I'm just going to call it the web from now on, through our web browsers, right? We browse the web through our web browsers.
Okay.
So we're using our web browsers to say, hey, this server has a hypertext document that I want to look at. Show it to me. And the internet sends you that information about what text is on it, and then your browser displays it appropriately. And that's what you're doing when you're surfing the internet. So to kind of understand this, we're going to break down what happens when we want to access a website. So this will just be an example. So when we want to access a website, say like Facebook, suppose you want to go to Facebook on your web browser. For whatever reason, you're trolling for whatever on Facebook.
You decided to actually go onto Facebook on your computer instead of your phone.
And not ironically. So you want to go to Facebook. So in order to do that, Facebook's URL, or its Uniform Resource Locator, that's what it stands for, it needs to be typed into the address bar. Or like if you search for a website and clicked on a link, then that's going to automatically populate the address bar with the appropriate information. So this URL is going to consist of 3 parts, or at least 3 parts. A lot of times there'll be more than 3 parts, but it's going to consist of the protocol, which is likely going to be either HTTP or HTTPS. HTTPS. It's hard to say fast. So it's going to have that. It's going to have the domain name, which would be like facebook.com, and then the path, which is everything that happens after the domain name, which is usually preceded by a /. However, the URL can also have many other things, such as subdomains, port numbers, if you remember ports from back in the previous episode, or no, 2 episodes ago? 1 episode. No, it was the last internet episode. I was trying to remember which layer I did what.
It was one of those.
Yeah, I think it was episode 13.
Yeah.
So it's going to have port numbers, queries, parameters, and fragments. So those are some other stuff that you could see if you're just examining your URL. So let's look at each of these in a little bit more detail so you can kind of know what's going on. What was that?
What?
Oh, I thought you sighed and
oh no,
like you were bored.
No, I was yawning. I'm sorry. I tried to back away from the mic.
Okay.
Which makes it worse.
That doesn't make me feel better.
It would be funny. Let's do a little plug to explain those URLs. You got the HTTP. And then you got www.facebook.com/thebestwaytoexplainit to get to our website that holds all of these in video format.
Facebook page.
Yeah,
but
Facebook page.
That's cool.
Yeah,
that's a good idea.
Yeah.
Go to that and like our Facebook page.
For sure.
But yeah, so we have, just to recap in case I lost anybody, so we have protocol, we have domain name, path, subdomain, port numbers, queries, parameters, fragments, so all those things. So we're going to talk about those real quick. So first we have the protocol. So as we know, this tells us how the web browser ought to communicate with the web server that's holding the website. So in this instance, we're assuming it's HTTP or HTTPS, which HTTPS is just HTTP, but it's encrypted with TLS or SSL, probably TLS because it's newer, which is just a transport layer encryption. So the layer just below this one has an encryption, which I think I talked about on the last internet episode. that does encryption. So that's what HTTPS is. It's just HTTP secure. So if you're doing any complicated like private stuff, make sure it's HTTPS, not HTTP, because otherwise you'll be sending sensitive information in plain text. That's really easy for people to get.
Yeah. Do you know what TLS or SSL stands for?
So TLS is Transport Layer Security, and SSL is Secure Socket Layer, I believe.
Okay.
Yeah, I think they're both just encryption, but I think TLS is newer.
Okay.
So I think it's replaced SSL.
Cool.
So other protocols might be FTP, which is File Transfer Protocol, SMTP, which is the Simple Mail Transfer Protocol, or IMAP, which is Internet Message Access Protocol, and that's just a few of many others that it could be. So that's what protocol is. And then we have domain or subdomain, which is both of those things kind of mean the same thing, but I'll kind of differentiate a little bit. So domains are just a convenient way that we use to hide the IP address of the website or web server that you're trying to access. So if you guys remember IP addresses from the network layer, which was 2 internet episodes ago, so it'd be part 4. See, it all just kind of fits together. So imagine having to remember the specific IP address of every single website that you wanted to access, or like whenever you searched for a website in a search engine, instead of getting the name of the website, you just got their IP address. That'd be pretty inconvenient, right? Like you would have no idea what's going on unless you somehow memorize those in your head. So what we've done is we use these things called domain names to make it easier to specify which hypertext documents, which are just the web pages, that we want to access. And these domain names are then converted into IP addresses by something called DNS, which is the domain name system or service. I still can't remember which one that is. And we're going to talk about how that kind of works a little bit later, or talk a little bit more about it a little bit later. And then subdomains are just domains within domains, kind of what it sounds like. If you think of it like a tree-like structure, so you have your top-level domain, just at the top, and then it can branch it from that top-level domain. You can have multiple mid-level domains and, so on. And so these domains and subdomains are organized from right to left. So the more general domain is going to be all the way on the right, and then the more specific ones are to the left. And that's, when I'm saying right to left, I mean in the URL. So the farthest one on the right would be your top level, and then your mid-level, and then your machine name, which is usually right next to the www, if that's, if you're using that. And the domain names are separated by a dot or a period. So actually, most websites are under the .com domain as their top-level domain. So a lot of websites have the same top-level domain. And you'll often run into different top-level domains such as .org, .edu, .gov, or even stuff like .ca, .uk, .jp. And if you see those, you're going to know a little bit of information about what kind of website you're at, or even like where the website's located. So you can just Google what each of these domains kind of means, and then you'll get some pretty good information about that. So like .org, I think it's like nonprofit, I want to say.
Yeah.
.edu is university or something. .gov is government, obviously. And like .ca, I think is Canada. .uk is, UK.
United Kingdom,
.jp
yep. Japan.
is Japan,
Yep.
I think. And so like basically everything that is separated by dots is some sort of domain or subdomain. So Facebook.com has Facebook's on the top level domain com, which I believe is commercial, if I remember correctly. And then its mid-level domain is Facebook, right? And if they had another one, it would be like, so say you want to go to like the videos of Facebook, it'd be like video.facebook.com. I don't know if that's a thing, but that'd just be an example of, or like Google Docs. It's docs.google.com. So
Okay.
com would be the top level, Google would be the next, and then under Google, another domain would be docs.
Okay.
So that's kind of domains. So you can buy these. That's what people do. You buy domains from providers that give you those domains, and they're like, I don't know, what do we pay? $10 a year?
Yeah.
For ours?
Yeah.
Something like that. They're pretty cheap.
Yeah, it's like GoDaddy.com is one of them. Stuff like that.
Yep.
Unpaid advertisement for them, I guess.
Yep. I guess.
I don't know who we actually get ours through.
I'm not sure.
Probably podcast websites or something, but
Yeah, I don't know if
Yeah.
they do their own domain provider, but yeah. So that's domains. And then another thing you could see is a port. So we know what ports are because we talked about them last time. And sometimes you'll see a colon after the domain name and the port number you're using, although this usually isn't seen. So a lot of times you're not going to see this, but if you see a colon and then a number, that's the port number that you're using. And you're really only going to do it if you're not using the reserved port that is used for HTTP, which is 80, or the reserved port for HTTPS, which is 443. So it's only if you're like explicitly not wanting to use the reserved ports. So
Okay.
that's why you usually don't see it. The next one you can see is the path. So the path is what you'd see after the domain name stuff, assuming there's no port number. And it's usually signified as starting with a /. And basically the path is just a file path that tells the web server you're communicating with kind of where to look for the hypertext document to display. So that's why when we tell you to go to the show notes page for this episode, we tell you to go to thebestwaytoexplainit.com/15, which when you type that in, it's going to tell the web server that hosts our website to look in the folder named 15 for the page that displays the show notes. And it's similar to the file path that you might see on your own computer if you use the File Explorer for Windows or, whatever it's called for a Mac. And so that's what your / is doing. It's saying, look at this document. Okay. Or folder or whatever. So that's the path. Then we have the query. So queries are found after the file path on what are called dynamic web pages. So these are pages that change based on certain like user-generated content. So suppose you were to log into your account on some website, you're likely going to see a query in the URL. Well, it depends a little bit, but that's not important. You're going to likely see a query in the URL that would give the file found at that path some like user-generated values, and the query part of the URL is usually started with something that looks like a $Q $, and then you'll have your query specified. So if you ever see that in a URL, that's what it is. And a lot of times you'll see that in like search engines. So if you do a search, you'll see a $Q = something, and that's your query. So that's using a HTTP GET request, and you can also use POST requests, which are passed through forms on the website, and that's not terribly important, but that's just a little fun fact thrown in there. So then we have parameters. So the parameters refer to this like the snippets of information that you might find in like the query string of a URL. So you're going to often see these parameters separated by the ampersand symbol. These parameters are just variables that the dynamic web pages use to display the correct information. So suppose you were to like submit your login information to Amazon so that you want to look at your specific wish list that you've created. Well, Amazon has a certain way it wants the wish list page to look, and this is likely going to be defined by what's called an HTML, which is the hypertext markup language document. So HTML, that's what it refers to. But that page doesn't know what's in your wish list, right? It can't know that just because they can't hard code a certain page for your wish list for every single user of Amazon. That would be, a lot of work that they don't want to do. So what they're going to do is it's going to use the parameters that you've given it in order to retrieve the correct information about your specific wish list. And this information is likely going to be like your username. So it's going to check your username against its data. It's going to get against the information stored in the database that contains the wish list information of your specific account, and then it's going to take that and then display it in the way that Amazon has determined that you ought to see it. So the name of the parameter is usually going to be denoted by a word followed by an equal sign. So the left side of the equal sign is the name of the parameter, and the right side is the value. And this name is just for when you're looking at like the HTML document or the JSP document. That's just a programming language that people use. That way they can refer to the information that you've given them in a certain way. It's like a variable. So that's what a parameter is. So if you see that, that's what that's doing. And then finally, you'll sometimes see a fragment, which is just an internal page reference that's sometimes called a named anchor. So this fragment's located at the end of the URL, and usually is going to begin with the # followed by some identifier, or the hashtag, I guess is what the young people are calling it these days.
#.
So it's going to, yeah, I agree. So the # followed by an identifier. So the fragment just specifies some section within the web page you're viewing. So sometimes you can click on a link and it'll take you to not only to a certain web page, but also to a certain, like, it'll scroll down a little bit for you. That's what the fragment's going to do. It's going to say, go down this far when you get this link. So that's basically everything that's in a URL that you might find.
Okay.
And so when you're examining it, that's kind of what you're looking for. So that's a URL. So after you would, going back to our example of HTTP, you have to, first you're going to type in Facebook's URL. So after you've typed that in, the web browser you're using is going to connect to what's called a domain name server and then retrieve the corresponding IP address for Facebook's web server. So this domain name server uses a protocol called DNS, like we talked about, in order to translate Facebook's entire domain name into an IP address. It's not really important kind of how DNS works internally, but just know that it does, because it needs to make sure that it's getting its information from the rest of the URL from the correct server, which is just a device on the network. So obviously that server has an IP address, but we don't want to have to know that IP address, so we use its domain name to reference it, and then it can do the DNS magic, right? So after the DNS does its magic, then your web browser is going to connect to Facebook's web server and then send an HTTP request, or whatever type of request you've specified in the URL, but it's likely going to be HTTP. In Facebook's case, it is. So then once your web browser sent the HTTP request, your Facebook's web server is going to receive this request and then check to see if the path that you've specified actually exists. So if it does, then the web server will send your web browser the information about the web page, which is usually just the HTML document, right? But if it can't find the web page, then it will send an HTTP 404 error. So you've probably seen this before. If you've ever typed in an incorrect URL, it just means that the web server you've specified, it just can't find a web page that matches the file path that you've given it. So then, assuming the URL you've entered is valid, then your web browser will get the web page back, and then the connection that you've established with Facebook will close. So you'll just have this page in front of you with no real connection to Facebook. So your browser's going to parse through the web page that it's received and then look for non-text-based things that it needs to finish displaying the web page properly, such as like images, applets, and then other things. So it's going to look for any HTML elements that say, hey, this is an image here. Here's where to go to get that image. And so then it's got to check and see if any of those elements are needed, and then the browser is going to make the additional connections that it needs in HTTP requests to the Facebook server in order to get those elements to display. And then finally, once all of the elements are loaded, then the page will be completely loaded, and you're off and running, trolling around on Facebook, seeing what those cooking videos and watching them, to their bitter ends. So that's what happens when you type in facebook.com and log in.
Yeah, you just ultimately end up on cooking videos.
Basically.
Yeah.
Yep.
Happens to me every time at work.
Mm-hmm.
I spend a nice, 30, 45 minutes reading normal Facebook stuff, and then all of a sudden, cooking
down
videos.
the rabbit hole of cooking videos. All right. Okay, so that's more or less HTTP and the web. Now, obviously, this is the most common application layer protocol and like the most common thing to do on this layer. But there are other application layer protocols that are worth mentioning as well. So the first one we're going to talk about is SMTP. I talked about this, I think, or I just mentioned it, I think, a bit before we started talking about HTTP. So this is the Simple Mail Transfer Protocol. Simple Mail Transfer Protocol.
You can transfer mayors over the internet?
Yep, yeah, it's brand new technology.
Crazy.
It's pretty great. Yeah. So this is the protocol that's used when you want to send email. So basically, here's what happens when you open up your email client, which is like Gmail, Outlook, whatever you use. Hotmail, if you're still old. AOL, Windstream,
Yahoo.com.
all those. Yeah. So first thing that's going to happen is that the mail client is going. Now this is mail, MAIL, not MALE, but okay. The mail client is going to open up a connection to its default mail server. Now the IP address of the mail server is typically installed by default to the mail client, so it's going to know this kind of just, it's kind of hard coded in there. But then the mail server is going to send a message to the client, okay? So after this message, the client is going to send an SMTP hello, or HELO command that the server responds with a 250 OK message. So client sends hello, server responds 250 OK. Now once this is done, the appropriate SMTP commands will be sent depending on whether the client is checking mail, sending mail, whatever else you do. Deleting mail. So these commands are going to be sent back and forth until the client sends an SMTP quit command to the server, and then the connection's going to be closed. So this is not connectionless like HTTP. It maintains its connection and sends stuff back and forth. So that's SMTP. So that's what happens when you're sending an email or checking your email. Then we have FTP, which is the File Transfer Protocol. So this is the protocol that's used when you want to share or copy files from around the world, just not on the same LAN. So not just on your same LAN, but if you want to copy from everywhere else on the internet. So to do this, you need an FTP client, which just manages the FTP stuff for you, right? And now I'm not going to go into the specifics of how FTP works, but just know that if you want to copy files from someone else's computer when they're not on your LAN, you need to use FTP. So fun fact, it actually uses 2 ports, an incoming and outgoing port. So most FTP servers use port 20 as their so-called data port and 21 for their command port. So data is going to be sent on port 20, and then the commands for FTP are going to be sent on port 21. So that's kind of interesting because most of these application protocols only use, one port because they only need one connections, but FTP is really inefficient and uses 2. So, yeah.
Cool.
Fun fact for us internet nerds that know what ports are. All right, so the next one we're going to talk about is DNS, which is Domain Name Service or System. So we've already talked about DNS, but it's worth mentioning that it is an application layer protocol, even though it does important things for both the network and application layer. So it's another application layer protocol that runs on the application layer, but it does network layer stuff. So a little bit of inception there, but kind of fun. So then we're going to go talk about DHCP. So this is the Dynamic Host Control Protocol. So I briefly mentioned DHCP when I talked about the network layer. Now, this is another application layer protocol that does stuff for the network layer, so it's like DNS. So this protocol is used to give out IP addresses automatically to devices on the same LAN. So your router does DHCP when you set up your computer to receive an IP address automatically. So if you go to the setting on Windows, your network settings, and you configure it to receive an IP address automatically, your router is going to do DHCP to send out a IP address to your computer, or assign it an IP address that from a range that you've specified. So that's what DHCP does. The next one we'll talk about is SSH. So this stands for Secure Shell. Now you may not have used SSH before if you're not a big computer buff, but it is a common protocol or application that's found on the application layer. It's often going to be used for remote login to computer systems by users. You'll often see it used in the command line environment. So you could use SSH if you use the command prompt on Windows or terminal on Mac or Linux. So now that I think about it, though, Windows might not support it yet.
I think it does.
Okay.
But you have to download certain programs, so it's not automatically on the command line. You download a program, and then you can use a secure shell. I used it for my Java class in college.
Well, right.
Yeah.
You can use you can download PuTTY, but it doesn't support it in its command line. That's what I'm saying.
Yeah.
Or it might not yet. I think they were planning on supporting it in the future, but I'm not entirely sure if that's a thing yet.
Yeah.
But SSH uses port 22 by default. So if you look for processes running on port 22. That'd be SSH.
Cool.
And then finally, there's Telnet we'll talk about. So Telnet's basically the same thing as SSH, but unlike SSH, it does not use encryption. So it runs on port 23 and probably shouldn't be used because of the lack of encryption, in my opinion. So you may as well use SSH just because you may as well encrypt what you're doing. So that's Telnet. So those are just a few of the other common application layer protocols that you might find. If you find others, just understand that they're located where they're kind of located in our network model, and you could figure them out fairly easily. So, yeah, that's the best way to explain the internet, my man.
Wow. And it only took you 6 episodes.
Only 6 episodes.
I'm so proud.
So, so from here on, it's you have a nice base of understanding the internet. And like I said, you can branch out fairly easily, just kind of understanding what the problems each of these things are trying to solve. So that's what you want to focus on. You want to, whenever you're trying to learn something new, especially about anything technology related, just always think to yourself, what problem is this technology trying to solve? Because if you're not thinking that way, a lot of these technologies can seem very ad hoc and kind of just thrown together. But if you think about the problems they're trying to solve, you'll likely find the real reason why this technology exists. So that's just my helpful tip for you, and hopefully it was a helpful thing for you guys to learn about the internet, and I'm really glad I got to be able to do all this. So just remember that not every single thing about the internet is going to neatly fit into one layer, but just the layering system is just kind of like a helpful heuristic for learning. And yeah, so that's the best way to explain the internet, my man.
Cool. I have a kind of a question.
All right.
So you've obviously talked about a lot of the internet, but are there things within the internet that you didn't talk about that you'd recommend for further learning? Yeah. So what you might want to look at are look more into hardware stuff. So routers, switches, hubs, modems. Get deeper into the hardware aspect, because at least when configuring your home network, you don't want to buy more router than you need, or you don't want to be spending more on like speed than your router or modem can actually handle. So look more into the hardware aspects of those. If you guys have any questions about that, I'd be happy to do an episode specifically talking about the hardware recommendations and everything that I might have. You can do that at thebestwaytoexplainit.com/suggestions. And yeah, just send that in, and I'd be happy to help talk about that. So hardware would definitely be one. Another one might be look into the technologies that ISPs use, so internet service providers, because they're going to provide kind of the backbone of the internet. They provide you with your public IP address and all of that. And so look into kind of how they go about getting you your internet, because that can provide a lot of helpful hints as to like where the problem might be if you're having issues with your network. So those are just some recommendations that I might have for further research. Nice. I would also recommend, it doesn't necessarily have to do with the internet, maybe a little more with CPUs, but it's kind of its own thing, and we might have to do a episode on it all on its own. But computer programming, before I learned computer programming, I had no clue what computers were actually doing underneath like the level of like me clicking and inputting a URL into the address. So check that out, because it will help you, one, understand what your computer is doing, and possibly help you understand like why your computer isn't working the way you want it to work if it ever crashes. And two, it'll help you with Excel spreadsheets, because very basic computer programming is within like really complicated spreadsheets. With like
they use conditional logic and all of that.
Ifs and ands and ors and stuff. So if you can like I learned Java, and I think that's really like the basic one that a lot of people learn.
Yeah, I would recommend learning Python if you want to learn programming language. I think it's the easiest.
Yeah.
So that would be my recommendation. And another thing I actually forgot, learn about basic network security is another thing, because you want to understand what a lot of the security settings are on your router. So I mentioned a few of them, like HTTPS, making sure that that's the case. Learn to recognize when a URL might be a little bit fishy, because a lot of times you want to look at which domains that the URL is actually pointing to, because a lot of times they can make it look like it's a valid domain, but in fact it's actually going to take you to a malicious website where they can maybe get some of your information. And then also just learn about, what you want to do for firewalls and what you might want to do for locking down your network. Make sure to change the default passwords of your router, because that's really easy to get into. Just basic stuff like that. So network security is another one you might want to look into. And now that you kind of understand what the internet's doing, you'll be able to better understand what these security applications actually do.
Nice.
Yeah.
Cool.
All right. Cool.
That's all I got. That's all I got.
All right. So remember, the giveaway is still going on for the Amazon Echo. You can enter that by reviewing and rating and sending the screenshot of that review to me at scott@thebestwaytoexplainit.com, and you can get entered for a free Amazon Echo that we will send and probably not sign, because that would be weird, to you personally.
Oh, I'll sign it.
Okay. Well, if you want us to sign it,
hey,
just
you
let
can
us know.
You can message us when we tell you you're the winner.
Yeah, and we'll look at you funny, but we will definitely sign it.
Yeah, we'll gladly sign it for you. All right, man.
Wow, that was arrogant. All right. On that note.
All right.
All right. Yeah, so like you said, though, like us on Facebook. We're on Facebook. Subscribe to us on YouTube if you want, if that's a desired location where you like to listen to podcasts. We're on YouTube, Facebook. I think we just started an Instagram.
Oh, yeah.
So look for us on Instagram. You can follow me on Twitter at ScottOlson25.
You can follow me on Twitter at Brecken Nielsen, BreckANNIelsen. Guaranteed someone screws that up, which is fine because everyone does.
Yep. But yeah, so if that is desirable for you, feel free to do that. So yeah, I don't have anything else. You got anything?
I'm good.
Cool. Peace out, nerds.
Get learning.